Hello, in this video we're going to configure SUSE Enterprise Storage Ceph. We will use SUSE Linux Enterprise Server version 12 with Service Pack 3 and Enterprise Storage version 5.5. On the picture you can see that we'll have 3 Mons nodes and we'll have 4 OSD nodes. All nodes will communicate via the Ceph public network, and for educational purposes I've added a Ceph cluster network. These are on different networks. In addition, each node will have internet access. This table shows the IP configuration. As mentioned earlier, all nodes will have internet access via DHCP. All the Ceph nodes will be connected to the Ceph public IP network, which will be on 10.10.10. The Ceph cluster network will only be for the OSD nodes, and it will be on 10.10.11. In addition, all networks are 24-bit. We'll use VirtualBox to create our SUSE virtual machines. So the first step is to go to File, check that our preferences are correct. So I'm going to use the D drive here. Just look at a couple of other things. Display, automatic, so that looks okay. So we'll do Machine, New. We'll give it a name. And the first name we're going to give it will be Mon 100 for the first monitor node. Change this to say Linux, and then we'll use other 64-bit and select Next. I have a fair bit of memory on this machine. We will create a virtual hard disk. We'll use the VirtualBox disk image format. Select Next. Dynamically allocate as well, which will only allocate data on demand, so you're not going to use too much storage space until you actually need it. Okay, if that looks good, we'll just make that disk drive a little bit bigger. And 30 gigs should be good enough. This will be our operating system disk. And we'll select Create. Just before we do that, we need to do a couple more things. We need to go to the storage, and what we will do here is we will load up a virtual ISO image, and we're going to select SUSE Linux Enterprise 12 with Service Pack 3. So this will be our boot system. Network, we're going to add a second adapter, and we'll make this host only, and start. So this will bring in the machine for us, and we need to select this to say installation. Just get rid of this annoying little, and hit enter. You can also remove that up above. So the first one will just close it, but we want to do not show this message again. And do not show this message again. Okay. So SUSE is now booting, and in a few moments we'll come to the GUI screen. You can see also SUSE Linux Enterprise version 12 with Service Pack 3, and also this right control. If you're not used to VirtualBox, then the screen might capture the mouse, and to free it you can do the right control key. That gets you back to your operating system. Once we've got everything installed, it should automatically do this when we move outside the focus of the window that we're running. Alright, so here's the GUI starting to come up. Okay, the system's just downloading some updates. Alright, so we need to agree to the license terms. Check keyboard layout is fine, and select next. The next thing to do is to register the system. So you need to have an account with SUSE for this. So this just should take a few moments while we contact the registration server. So select yes. And then we can decide what else we want to do. We could install SUSE Enterprise Storage 5 now, but what we'll do is we'll install the operating system first and then we'll do it later on. It's also possible that some people may not want internet access to their clients, so in that case then they would probably defer this and deploy it as an ISO image. So at this point we can hit next. We'll use the default system, which is the GNOME environment. And we only have one disk, so we'll use that one, SDA, and we'll go with the proposed settings. Select the time zone as appropriate. And then we need to add in a username. Give it a password. And for simplicity's sake, we'll use the same password for the admin root user. So this is a preview of what it's going to do. We will disable the firewall in our case. And we want to enable the SSH service. So there's the software, routing, kdump, and we'll come up in graphical mode and select install. Alright, this will take a while, so we'll just wait for that to finish. Alright, thanks to the magic of video recording, then we're ready and the system is just rebooting. So this time we can boot from the hard disk, seeing as everything's been installed, and it comes up with the correct OS. So we need to do some configuration at this point. Alright, now at the login, we'll go in initially as root, so hit not listed. So one of the first things we'll do is we'll change the resolution just to give it a little bit more real estate to work with. Okay, now the system's up and running, we need to go in and configure the network. So we'll use the AST tool for that. And then we'll go to network settings. So on the Mon node we have two network interfaces. This is because they only need internet access and also from the Ceph public network. The OSD nodes will actually have three. The third one will be for the Ceph private cluster network, which is used for replication. So the first thing to do is go to the hostname DNS. We want to change that. So we'll put in Mon 100 and we'll give it a domain name. Right, we need to go back to overview, and we can see that the second interface is set to DHCP. We need to edit that and change it to say static, and give this one the address of 10.10.10.100, the net mask of 24, and that should be okay. So we'll select next, and there's our DHCP. Everything looks good there. Let's click on OK. All right, let's have a look now at our terminal. And let's look at the two network interfaces. So 10.10.100, and you can see that the host name is also changed. So that's good. The next thing we want to do is to go to the add-on products. And this is where you'll need the ISO image for SUSE Enterprise Storage 5. We select add and local ISO image, or we can say, if we have it already mounted, it'll read the DVD. So you can select either a physical device here if you're doing this on real machines, or you can just do the ISO image. Either way will work. So we select accept, and there it is. We do continue. And then finish. So again, we need to register the system as we did before for Enterprise Server. Select OK after registering, and that should be good for the moment. All right, let's close that. Of course, you might find it easier to install the enterprise storage during the installation time. If you recall, there was a second option. This has the advantage that it'll always pull down the latest version, whereas if you use an ISO image, it's not guaranteed to be the latest. Incidentally, with version 5 at the time of writing, the image that's available is version 5, and when you do an upgrade later on in the system, this will automatically upgrade to version 5.5. So we're going to be using Enterprise Storage 5.5 in this demonstration. So the next task then is to complete the installation on all the other nodes. So we've done Mon 100, we have to do Mon 101, Mon 102, OSD 103, OSD 104, OSD 105, and OSD 106. So the next task is to configure our host file. So the one I've done looks something like this. This is the IP address I'm using to set public network. Then I'm giving the fully qualified domain name, and then I'm doing the short name for the host. So if we're happy with that, we'll save that file. And the next thing we want to do is enable communication with each of the device other hosts without having to specify a password. So first thing we do is we generate a key, and then we'll copy that key over to each of the different nodes. Now we'll just verify that this works. So SSH OSD 106, and there we go. So you need to verify this for all other nodes as well. So now what we'll do is we'll copy the host file to all the other nodes. So we'll use a simple loop to do this. So we just put in all the different node names here, make sure that we've got them all, and we'll SCP them across. And there they go. So at this point, a copy of etc host should exist on all the nodes. Every node should be able to be accessed using passwordless login from node 1100, which is going to be our master node. And in addition, SUSE Enterprise Storage version 5 should be installed on each of the nodes. So that's our checklist before we move on. So the next task is to configure the network time protocol. So we'll use our YAS tool for that. And under network services, we can see NTP configuration. So we want to have the NTP daemon starting now and on boot. And then we need to add an NTP server. So we'll make this one the server. This is on node 100. So here we're going to use the following external server. Select OK. Check everything is good and do OK again. So now we need to configure NTP on the other nodes. So looking at Mon 101, first thing we'll do is check to make sure that NTP is installed. So we can use zipper for that, and it is actually installed. The next thing we want to do is to go in and edit the file. So the line we're looking at is this one here. We want to make sure that we have this configured to use Mon 100 10.10.10.100, and once we've done that, we can save that file. So we can then enable that service. So there we go, and we'll just restart it in case it was previously running. There we go. So this command following will just let us see what's going on, and we can see that the server there is included, and we'll just check the time, and that is correct. The next task is to install the deep-c package. So deep-c will be used to deploy all the various stages of Ceph. So respond yes. You can see also salt-master and salt-minion are installed with this package. Previously you had to deploy them separately, but now deep-c will install them all for us together. This is also a good time to upgrade all the packages, so we'll upgrade them. Okay, it looks like we're all up to date, which is good. So now all systems should have been upgraded. NTP should be running and the date should be correct on all the different nodes, and we should have installed deep-c package on every single node. So our Mon 100 node is going to be what we call our salt master, and the rest of the nodes will be called salt minions. So we need to do some configuration. First thing we need to do is configure the salt master node. which in our case is Mon 100. So we'll enable the salt master package. And we also need to start it. We just check that everything is okay. Okay, we do have an IPv6 warning which we could fix later on, but we're really going to use just IPv4 in our case. So now that we've restarted it, we need to check the file minion.sls. So if we look at that file, we can see that it points to the master node, which is Mon 100. So that's correct. So we also need to edit and create the file master.conf. So the contents of this should be simply master, the colon, and then the node name, which is Mon 100. And we save that. So now we'll copy the file across to the Mon nodes. And then edit that string to copy it across to the OSD nodes. So now we need to do the same for the SLS file. So next step is to establish communication between the master and the minion nodes. So if we do salt-key-f, after restarting the minions, we get a list of all the unaccepted keys. So this is good. This shows that the master node can see every one of the minions. So what we need to do next is to do the same command, except this time we're going to do --accept -all. It should accept all those keys. And we will proceed, yes. Alright, so it says Mon 100, so all the keys have been accepted. And we'll just do list-all just to be sure. And it shows that they're now in green, they've all been accepted, nothing's been denied or unaccepted or rejected. So we have communication now between the master and the minion. The next task is to edit the salt minion specification file, which is at that location you can see in the screen. So server pillar ceph deepc minions.sls. So there's a number of ways of doing this. You can look at the comments there below to get an idea of what goes on, but we're going to be a little bit lazy here and we're just going to comment out this. So all the minions will need to be part of our cluster. So that's all we need to do for this particular file. So save that. So now we're ready to start deploying SUSE Enterprise Storage. I've split the terminal up into two windows. So this one, deep-sea monitor, is very useful. It'll allow you to see all the various stages. And when we deploy SUSE Enterprise Storage, there's a number of different stages which we need to go through. So the first one we're going to run is the preparation stage, and this is going to check for updates and make sure we've got connectivity, all those kind of things. So let's kick off the deep-sea monitor. Now let's start the preparation stage. So you can see the monitor showing that the preparation stage is starting, and it'll list all the various steps as we go through it. This sometimes takes a minute or two to deploy. So you can see over here that the minions and the master and the Ceph version is all valid. So it's just doing some checking. So here's the steps coming out. So step 1, step 2, and so on like this. So if there's any errors, you need to note which step is causing the error and then go and investigate as well. So here's step 6. Some of them happen very quickly, some of them will keep going for quite a while. Setting up the repos, you can see for all the various nodes, and you can see that they're all done in different orders, so it's true parallel processing. It's not doing them sequentially. That's the advantage of this kind of a tool over Ceph Deploy, where Ceph Deploy is mainly sequential. If you just give it a list of nodes, this one will just go along and it will do them all in parallel. So you can see that these updates are taking a little bit of time. It's created a few of them there. So it's succeeded, and we can see that everything's good over on this side. So in a virtual deployment, we can add really the disks at any time. If of course if it was physical nodes, then you would have configured them at the very beginning. But the beauty of the virtual machine is we can really do it at any stage. So I powered down the 4 OSD nodes here. And what I'm going to do is I'm going to go into Machine, and I'm going to do Settings. And I'll click on Storage. And what I want to do here is look at these little icons down below and add a new storage controller. So what we'll do is we'll add a SAS controller. Again, it's virtual. There it is. And what we need to do then is next add a hard disk to it. So click on this icon here, add hard disk, and we'll create a new disk. We'll leave it in VirtualBox disk image, dynamically allocated. We'll make it a small capacity of, let's say, 25 gigs. And we'll give it a name of OSD 103-1 for the first disk. And we'll do create. Now we'll add another disk. Give it the same capacity as before and do create. So now we've got 2 disks that we'll use for our system. I should have said 103 here, but it won't really matter. And now what I'll do is just to add a new storage controller, and we're going to make it NVMe. So now we'll add a disk and we'll create a new disk, and next, dynamically allocated, and we'll call it OSD 103-NVMe1, and we'll give it a capacity of, say, 16. Now we'll give it a capacity of 20. So the NVMe disk here will be used to house the write-ahead log and the DB for the OSD nodes. Even though these are all virtual machines, it will still illustrate the concept that I'm creating virtual devices. In the real world, typically what would happen is your data will be stored on spinners, HDDs, and then to improve performance, you could offload the block DB and the block wall onto the NVMe device. So we're going to illustrate this and how it's done with SUSE Enterprise Storage. So that's really the purpose of the NVMe. I'm not trying to enhance performance in any way. It's just really for the purposes of understanding to bring this in. So now what we have is the NVMe devices. We have the 2 devices which will be OSDs, and then we have the operating system disk. So if we're okay on that, there's our disk there, our system, and we can look at this and we can see all the various things that we have on it. So there's the adapters, Okay, OSDs, and everything's good there. So we need to do this for OSD 104, 105, and 106, and then reboot the systems. Alright, so now we're ready to run the discovery stage. This will go out and look at the nodes and discover the hardware, and it'll come up with some proposals. So you can see it's starting to run this using the deep sea monitor. Again, this will take a little while to run. But again, we'll leave it to run through everything to show on the video all the various steps. So if you do run into any issues, you might want to compare your particular run with this one that's on the screen. So this is important, the proposals that are being populated. Later on we'll look at these YAML files, YMLs, and this is where we'll see some of the hardware configuration. Alright, so that's now completed. So next thing we want to do is to look at some of these proposals. So we need to look at the directory /server, pillar, Ceph, proposals, profile default, stack default, Ceph, minions. So quite a lengthy string. Use tab completion, of course, to do this. So let's look at ls, and we can see that there's some YAML files for the various OSDs. Let's have a look at one of them. So what it's telling us is that the storage is dev SDA is BlueStore, dev SDB is BlueStore. These are the two hard disk drives. And then what it's going to do is it's going to use the NVMe device also as BlueStore. So this is really not what we want. We don't want to have 3 separate OSDs on the OSD 103 server. Rather, we'd have the 2 SDAs and SDB HDDs as OSDs, and we'll locate the wall and the DB on the NVMe device. So there's a couple of tools we can do to actually modify these YAMLs for us. So we can use this command salt-run proposal.peek. And what happens when we run this is that it will give us a preview or a peek of the proposed deployment. So what I'm doing here is I'm saying salt-run proposal.peek. For my data drives, I'm only going to accept data drives which are in the range of 24 to 26 gigabytes. And if you recall, we made our HDDs 25 gigabytes in size. So they'll be the only ones selected for that. The NVMe device will not be selected because the capacity is lower. In fact, it was 20 gigabytes, so it won't be considered as a data device. Then I'm specifying journal equals 19 to 21 gigabyte range, and that falls into the capacity of the NVMe device, which was 20 gigs. And I'm going to do a ratio of 2. The default ratio is 5. What this means is that the 2 HDDs will be shared with the 1 NVMe, so the ratio is 2 to 1. So if we press enter on this, it'll go out and it'll look, and it'll come back with a printout of what it's proposing. So this is the output. You could put it to a file if you want, but let's look at the output of OSD 103. So it's saying on device SDA, which is the first device being considered for an OSD, and it has the database which is located on the NVMe device, which is what we want. Format is BlueStore, and also the write-ahead log is also placed on the NVMe device. So that's good. On the SDB device, the database is also there, and so on like that. So that looks good. We can see the same thing for 106, 105, and if I scroll back up, I can see it from 104. So now I'm going to delete the existing YAMLs. So the peek command allowed us to have a preview of everything, and it looked good. So now that we're happy with it, we can change the peek to say populate, and this will actually write out the YAMLs. So let's hit that. Okay, so what we get is a number of different things here. Let's have a look at one of the YAMLs. So let's do 103 again. OSD 103 dot, and this time we see NVMe for the DB, NVMe for the wall, and then we see device SDB, and we see the same thing here. So that looks good. So we're happy with our YAMLs. Everything looks good at this configuration. So at this point, Enterprise Storage needs to know a little bit more about how we're going to deploy all our nodes. So there's a file called policy.config. You can see there it's in SRV pillar Ceph proposals. So we need to edit that. So what we have, if we look at this, is that the Ceph cluster has got a default name, and then for the admin role, we're going to use Mon 100. So you can see there the role master, so our master node, which we already know is Mon 100. So we need to have that in. And then for our Mon nodes, we're going to use all of the monitors. So we've used the wildcard there. So Mon 100, 101 and 102 will fit there. Also for the manager role, that will be all the monitors. And then what I've done is I've used Mon 101. I've kind of overworked it a little bit here to make it as a metadata server for CephFS. I'm not going to use an iSCSI gateway, but I have deployed role Rados gateway to Mon 102. The OpenATIC function, which will be the GUI we'll look at later on, will be deployed on Mon 100. And then you can see there's a few other roles here at the end. So that's what we need to do. That needs to be set up. And again, you can look at the Enterprise Storage Deployment Guide to get more information on this. So let's save that file. Okay. And we'll kick off the configure node here. Run. So we've done already the preparation stage. We've done the discovery stage. And now we're going to do the configuration stage. So that will start running here, and you can see on the Deep Sea monitor, we can look at that and see how everything goes on that side. So this is important to keep an eye out here, just in case there's anything else going on. So you can see we're running a number of steps. So far everything's good. Setting up keys for authentication. OpenATIC there, you can see it's been deployed to Mon 100. All right, we're nearly at the end there. You can see that there's still a bit of work going on here. All right, and there we go. So everything is good. If we scroll back a little bit, we can actually see that on OSD 103, 104, 105, 106, it's telling you that it's going to deploy these devices /dev/SDA. Also, if we look at the networks, public network 10.10.0, which is what we want, and the cluster network will be 10.0.11. So that's all correct. It may be possible in some configurations that it doesn't get it quite right, and you may need to go in and edit the network files. So if the network configuration is incorrect, you need to go into this folder here, SRV pillar Ceph stack Ceph, and the file that we're interested in is the cluster.yaml. So if we look at vi cluster .yaml. We can see a number of comments in there, and what we would need to do is to come down below that, and we need to enter public underscore network and then 10.10.10.0/24, and also below that you would put in cluster underscore network 10.10.11.0.24. In our case, though, everything's good, so we will not need to make any changes to the cluster file, but that's where you would go if you ran into any issues there at that point. So we can use salt to have a look at the inventory of each of the items, so we can look at the rows and other functions. So what I'm going to do here is I'm going to have a look at Mon 100. So that's the command there, salt node name pillar.items. You could also use a wildcard to dump all the rows for every one of the nodes. But first of all, let's just look at Mon 100. So if we scroll back here a little bit, you can see that the available rows for Mon 100 are listed here. So there's quite a few things. You can see iSCSI, NFS, Radius Gateway, a few various things like that. You can also see the cluster network 10.10.11. You can see the public network, and then you can see the rows that have actually been assigned are master, admin, mon, manager, and openattic. And again, these were the things we put into the policy.config file. Let's just have a look at Mon 101 and see how this one differs. So if we look there, we can see that the metadata server role has been assigned to Mon 100. Let's just have a look at one of the OSD nodes. So let's look at 105, for example. And we can see the only role there is storage as well. And the networks are all correct. So everything looks good on that front. So now we've done the preparation stage, we've done the discovery stage, we've done the configuration stage, and we're ready to move on to the deployment stage. So salt-run state.awk ceph .stage, and we're going to use some shorthand here. We can actually just put a number in. I'm going to put in 3. So 3 corresponds to the discovery phase. The 2 would have corresponded to configuration, 1 to deployment, 1 to discovery, and 0 to deployment. So this is just a little bit of shorthand, but it's really the same thing as the discovery stage. So let's run that command, and let's shoot over to here. So this is actually going to deploy Ceph for us now at this point. Later on we need to set up all the various services, which is stage 4. But at this point we're going to start deploying Ceph. So Ceph should actually show up fairly soon. And what we'll do is we'll add in another little terminal window here. And we'll do Ceph-S. It's probably a little bit early in the stage for this to be running. Yeah, so let's leave it a little bit longer before it gets further into it. But later on we'll be able to do this. Okay, so now it's setting up the various roles. So it's setting up the packages. All right, we're starting to get some, so let's look at and see if we can get some activity. So watch Ceph-W. So this will give us watch-S because we're using the watch, so we need to do the status. All right, so we can see that the Ceph cluster is running. This is the ID of the Ceph cluster. The health is okay. 3 monitor daemons, which is what we want, and there they are there. The manager is actually using 102 as the active, but 100 and 101 as standbys, and you can see the OSDs are being created. So we made 2 OSDs on each of the OSD nodes, so 2 times 4 will give us a possibility of 8, and there's 8 coming up. 4 still have to come in, but we have 4 of them running at the moment, and there they go, 8 up and 8 in. So at this point the cluster is actually up and running, and it looks very good. There's still a little bit of work going on, but essentially we have a cluster. So we could create pools, we can do lots of things, we can do other Ceph commands. So let's just have a look at the output of Ceph OSD tree. So what we have now is these are our nodes here. So if we look at host 103, that's housing OSD 0 and OSD 4. Host 104 is 2 and 5, 105 is 3 and 6, and 106 is 1, 7, and 8. So if you look at the weight here, you can actually see that the HDDs are just a little under 0.024. So this is actually the weight in terabytes. You might recall we made these 25 gigs in size. So if you look at these, then the 2 of these totaled up here, the capacity, and then they're added to give the weight of the actual host. So the weight of each of the hosts is roughly 50 gigs in size, and then if you look at this, this will be around 0.2 of a terabyte, or in other words 200 gigabytes for the total cluster. So this is the total cluster up here. This is the weight of the individual nodes, and then this is the weight of the individual hard disks. Let's just have a look at OSD 104, and let's do an LSBLK on that. So you can actually see that SDA and SDB have been set up, and you can see the OSD node numbers here, 2 and 5. So this is how we can look at Ceph OSD tree. We can look at this and we can see that we have OSD.2 and OSD5. This shows us that they belong to node 104, and they're actually deployed in /dev SDA and SDB. If we look at the NVMe device, you can actually see there's 4 partitions, and each of them are 500 meg in size. These 4 partitions are the block and the DB, the wall and the DB for each of the devices. So you can see that 2 of them will be allocated to house these functions for SDA, and the other 2 will be used to house these functions for SDB. So the 4 partitions are exactly what we expected. And you can see also that the SDA 1 and 2 are broken up into 2 partitions as well. There's a small metadata area, and there's also the main data area for each of these as well. All right, so let's just look at this again, and there we can see everything's looking good at this point. So just to test it, we'll create a small pool called test pool. We'll give it 256 PGs, and we'll use replicated. All right, so again, if we do Ceph-S for status, you can now see that we've created one pool, and you can see a little bit of area is used. So you can see also that they're still creating and peering. So let's just do this again, and now everything's clean. So there's all the PGs clean, and everything's good. So we can perform a benchmark on it just to do some testing, make sure everything works. So Rados bench -p, the pool name, which was test pool, and we'll write out the default 4 meg objects for a period of 50 seconds. So here we go. So let's just maximize this a little bit just to give you a better idea of what's going on. So you can see the average megabytes is around 150 megabytes a second. The current is here, and then we can look at the latencies as well. So the default here is the 4 meg objects, which you can see there, and 16 threads. So the 16 current writes of 4 megs. So that's what's going on, and up to 50 seconds as well. So effectively it looks like, from what we can tell, basically our hardware is working, our Ceph cluster is up and running, all the nodes are functional, and we're getting a reasonable throughput. Again, this default for Ceph is 3 times replication as well. So let's just bring that back to its original site, and there we go. So you can see that the bandwidth was around 128 megabytes a second. There's the block size, IOPS, etc., etc. So there we go. So the final stage we want to run is stage 4, which configures all the various services and will allow us to run metadata servers, OpenATIC, and everything like that as well. All right, so here's our deep sea monitor, and what we'll do is we'll just have a look at the Ceph configuration. So there's our pool that we just created, 256 placement groups, and this will probably take a while to run. All right, so we're getting a little bit of activity there. It's actually creating some default pools here. This will be for the Radius Gateway most likely. Later on we'll have a look at all the different pools, and also metadata for CephFS as well. So you can see what's going on here, 512 PGs. So you can also see some IO activity there going on. So here's CephFS on the metadata server. That's where we're getting the extra PGs from that second pool. And we have a third pool here. So here's more pools created, and these are most likely the Radius Gateway pools coming in. By default, they create very small PG counts of only 8 PGs. So even though there's 7 pools, the majority of these pools will be not for the Radius Gateway ones. So as this is going on, we can see a little bit more activity. And previously you can see the gateways being created there. So it usually is quite enlightening really to have Ceph-S running. You can actually see what's going on behind the scenes as well. So there's the Radius Gateway, 1 daemon active. CephFS is running. There's the monitors as normal. We now have 7 pools. So this is again starting up the services. So even though you can run everything after stage 3, you can't run all the other various functions and the rows that we set up in the policy.config. That's what stage 4 is for. So you can see now we're at OpenATIC. That's all running here. So I'll tidy up these particular rows. Okay, so we're nearly there. And we'll just let that run to completion. And there we go, stage 4 succeeded. Everything is good. So let's have a look at the pools that have been created. So there's our original one, test pool, CephFS data, CephFS metadata. So for CephFS, you need to have 2 pools, one for the data and the other one is for the metadata. So the file component to Ceph is the only one that uses a metadata server. If you're just using block and object, you don't need this as well. There's a number of Radius Gateway pools as well, which are here. So now that the system services are installed, we can have a look at OpenATIC. This is the GUI that SUSE provides to give you more insight into your cluster. So to enter this, you do mon100/OpenATIC. And then the username default is OpenATIC, and password is also OpenATIC. So we press enter there, and this will bring up the dashboard. So this gives us a good overview of the system. So the health status is okay. There's 3 monitors, 8 OSDs all in, 7 pools, 8 OSDs all up, none of them are down. We can also see things like latencies here. We can also scroll down and get a bit more information. Objects in the cluster, there's really not much happening there. There's other stats that we can see here. The PGs are all active. If there was recovery going on, we could get in and have a look at that as well. See how well balanced the OSDs are for utilization. If we look at the OSD tab, then we see all the various OSDs here. The blue store format. There's the crush weight that we discussed before. If I select random OSD 0, I can get a bit more information. Again, it'll show me the utilization, the PGs, the variance of the utilization, latencies, various tools like that as well that are useful. If we look at pools, we can see the pools that we created. So the RGW, CEFFS pools, these are for the metadata and the data, other RGW pools as well. And then there's the test pool that we created earlier. So this is where we ran Rados Bench. So if I click on it, we can see it's a replicated pool, that's the name of it. 3-way replication, number of placement groups are 256. With Luminous you had the ability to use compression. We are not going to use that. And that'll cover that. If we look at the Rados Gateway, we can get a little bit more information here, though we haven't really done anything with the gateway configuration at this point as well. So a couple of other areas, crush map, which is useful. This shows us the nodes here. We can look at that in more detail. What else? System. We can look at settings. There's really a few things in here to look at. So this gives us the host name, the object gateways. We're also using Grafana as well. That's what's going on behind the scenes. API recorder. This is something that you could look at as well if you're interested to see some of the APIs. This is the user open attic. This is where you could change the password. And I'd encourage you to look at that in a little bit more detail. So that's the end of the training, and thank you very much for staying with me, and happy hunting with SUSE Enterprise Storage Ceph. Thank you.